Okay, number 6. The block against the vertical wall using friction so that it doesn't slide downwards. How much force do you need to push it against the wall? If the kinetic, static friction coefficient is 0.55. Okay, in the case here, a block is being pressed with force Fa against the wall. So the wall will react to push it back on the block with Fn, and of course you also have Fg acting. So look at the three-body diagram. So because it's a state at rest, according to Newton's second law, all the net force should be 0. So we, in most of cases, we always be aware that we consider two directions. If it's net force equals 0, that means the horizontal net force equals 0. We can get a conclusion that Fa equals the Fn. Right? As long as we can find out the Fn, so we can find out the Fa, which is what's the question asking for. And also vertically, you can also see the Ff equals the Fg as well. Okay, now here the friction here is a static friction. Now for the static friction, so we know Ff is always less and equal than the Ff maximum, which equals the mu s times Fn. Okay, now the question actually implied to asking for how much force you need is actually asking for what's the minimum force. So it's asking for minimum force. Okay, so if you analyze this equation, so in order to make the Fn being minimum, and then you have to make this one to make the friction force the maximum. Okay, and then because if this is maximum, and so actually you can think this way. If you apply with the Fa very big, so if you use this formula, you can calculate the maximum friction would be also very big, but that's not necessary, right? As long as the friction is big enough can support the gravity, that's enough. So the normal force required is multiply the mu s, provided the friction which make it equal to the Fg, and then the block won't slide down. Okay, so that means this is going to be the equation. So friction maximum equals mu s Fn, and as long as you make the maximum friction just equal the gravity, and then it won't slide down. So in that case, you can find out the Fn equals the Fg divided by the mu s. Okay, so you can calculate this, mg divided by the mu s, and plug everything in. 2.0, 9.8, 0.55, and if you calculate, it should be 36 Newton. Okay.